Hello and welcome back to the Harrier project. Meanwhile, this is part 9. And in this episode, we want to check the Harrier wing, how it behaves, what is the lift and what is the stall behavior. And for this, I built this new jig. This is rotatable, so the AOA can be changed. And also there was a lot of progress on the Harrier itself. You see it's now nearly completely assembled. And I would say let's start with the building process of this jig. And then I want to show you the whole test area and the idea behind this. And last but not least, we want to do some tests here. So let's go. I would say it's time for a new test stand. This time I want to check the lift ability of the Harrier wing. And for this my idea is to use this plate and this wood, and on the top of the wood there will be a bearing to make this wing swivel to work with different angles of attack. I prepared already this. This is a brushes with 2 ball bearings. In this comes this composite rod. And all this will put on the scale. Per wing we need a lift of about 1.2 kilograms. And then we check different Vortex generators. These are these small guys on the nose of the wings. And the first step is to put an extra root rib on here, that the whole wing is in a good airflow. I marked this rib already on this styrofoam piece, and now we want to cut this out here on this hot wire cutter and then bond this on the wing. Let's go! So some steps further it looks like this. Here we got the jig with the rotatable attachment for the wing. 2 ball bearings and 16 millimeter composite rod. Here is the wing, already with the styrofoam extension and also with the plate for installation. So here we got the test wing. I filled the gaps with some micro balloon to make it nice and smooth on the surface. And the next step is grinding it down. This is 180 grip with the angel grinder, and I would say let's go. So now everything is ready assembled. Here we got the wing with the stripes and a neometer to see the wind speed, and here are the 4 EDFs, 90mm. They can produce a wind speed of up to 250 km per hour. and let's start and see what happened. And we can see that the whole thing, the whole wing starts shaking, and this is caused that the wind that comes out of these EDFs is quite turbulent. So we have to smooth it a little bit up, and my idea is to use this honeycomb. Yeah, I will build a frame, and you can see through here and guide the air through this honeycombs. This will be installed right behind the EDFs. Yeah. And let's see if we got a better result. Let's start. So here we got the wooden frame and some honeycomb. This is 5 mm thin. I will do the cut out and put it on the frame. Let's go. So here we are, everything is ready installed. The honeycombs right behind the EDFs. And I would say, let's do the first test. So, yes, it is not that what I was looking for. There is a big loss of wind energy or wind speed because of these honeycombs. We just got about 50 km per hour, and yes, and also there are some turbulences left. So I would say I rebuild this and do the test without this. Maybe there are some turbulences, but for me it is interesting to see if the result we got from here is reliable to the results we got up in the air when the wheel thing is flying. This is just a pre-testing. So I will start now without the honeycombs and see the results, and in 1-2 weeks we will fly it, and then we can see if this fits to reality. So let's start. So we saw the first test run, and what I was doing here is putting this wing on a scale. So on this display you will see the weight, which is lifted. So this is why there is a minus, because there is no pressure on the scale. There is a lift up on the scale, and I take a look on the lift of the wing on different angles of attack. 12 degree and 24 degree. To also see the stall behavior. And all these results are marked here. I start with 40 km per hour and then go 10 km per hour up and up to 70 km per hour. And this I do with all these different, and I would say let's go on with the tests. So rail number 2 is going to be tested with some small vortex generators. Let's see. Yeah, this was the testing, and the differences between these vortex generators and without vortex generators, they are not that big. Here we can see it. Yeah, with the first test without any vortex generators was starting at 200 grams and go to 630, and the worst result was this green ones, angel of 15 degrees. Yeah, so they are not straight. Every second of them shows a little bit to the inside. This was the worst result. Yeah, this was about 100 grams below. Yeah, but nevertheless, the really best result was with this small Vortex generators, these absolutely small ones, yeah, number 2. And I think this one we will install on the wing. Yeah, this will be used for the maiden. I'm a bit disappointed from these Vortex generators, yeah, that there was not a bigger difference, but nevertheless we saw that the wing, the airfoil is the Clark Epsilon, and it has a very nice stall behavior. Yeah. Quite all over the wing was a good airflow. I would say thank you for watching these videos, and if you like it, I would be happy if you buy me a coffee. The link is under the description. I want to thank also the guys who already did. Yeah? And I would say see you in the next video. Bye bye.
you.